Hey guys, this is the final exam review. This is question 19 of 21 or 9.2.4t. I'm just going to work it out for you, help you through it a little bit. Says consider the hypothesis shown below, given that bar x is, that's the sample, sample mean is 115, the population standard deviation is 27, n equals 40, alpha equals 0.01, complete parts A and B, and then it gives us a null hypothesis that the population mean is 123, and that the alternative would be that it is not 123. So right off the bat, we can tell that this should be a two-tailed test. Anytime that this is an equal or a not equal to, that's a two-tailed test, meaning that we're testing for some mean here of 123, and we're going to reject that hypothesis if we get too far above the mean or too far below the mean. Okay, so the first is what conclusion. Okay, the first is the z-test statistic is. So to calculate our z-test statistic, we need some information. The reason we can use a z-test here is because we know the population standard deviation that's given to us. Sometimes it's not, and then we'd have to use a student's t-distribution. But here we do know it. So the information we need is the bar x, which is given to us, right? Here it is, bar x is 115. That would be the sample mean. We also need the null hypothesis, or in other words, we need the population mean from the null hypothesis, which is given to us here as 123. We also need the population standard deviation, which again is given to us here as 27. And we need the n, for the number of data points in the sample, and that is given to us right here as 40. All right, once we have all that information, we can calculate our test statistic. Whoops. Our test statistic is going to equal our bar x minus our null hypothesis divided by population standard deviation divided by square root of n. There's our test statistic. Because this is a two-tailed test, it's going to show as either a negative 1.87, what's it want, 2 decimal places, or a positive 1.87. What this means is, oh, I take that back. This is our test statistic. So that negative and positive, it's just a negative 1.87. Okay? It's the next part, the critical z, where we need to do it as a negative and a positive so that we can compare and see if the test statistic falls outside of the critical z, either as a negative or a positive. To calculate our critical z, we're going to use a function which is norm for normal dot s dot inv, and then the probability. Now this is a little confusing, but because this is a two-tailed test, our probability that we're looking for is half of the alpha. So the alpha is 0.01. So the probability we're looking for here is 0.005. We can also come up with that by looking at the tables for critical z-scores. And if you look on that table, it'll have it broken down into whether it's two-tailed and one-tailed, and you can get the same thing. But you can use this function in Excel. And this is the one that we're going to list as both a negative 2.5, how many decimals do they want? 2, so 2.58. Whoops. Negative 2.58, comma, 2.58. That's a way of saying if our test statistic falls less than or to the left of negative 2.58 or greater than or to the right of 2.58, then we'll reject the null hypothesis. In this case, though, it doesn't appear to. So let's make sure that's right. Now it's going to say, because the test statistic does not fall within the critical values, is less than the critical values, falls within the critical values, or is greater than, in this case it falls within, then we will not reject the null hypothesis. And then it wants us to find the p-value, or the probability of this z-test statistic happening. So to find our p-value, we're going to use another function in Excel. This one's called norm.s.distribution, or .dist. And then we're going to use our test statistic as our z. And for our cumulative, we're going to put true. Now again, what that returns to us is the probability of some data point falling to the left of the test statistic of a z of negative 1.87. Because it's a two-tailed test, though, we have to take 2 times that, because we want to find the probability that it falls either to the left of negative 1.87 or to the right of positive 1.87. So our probability here, our p-value, should be 0.061, or a 6.1% chance of that happening. And that should be it for 19 of 20.